Hi everyone, Daniel Brisson from FNL Freedom News, Nouvelle Libre. Again, we'll have an interesting moment again with the professor and Dr. Avi Loeb about the last news of 3i Atlas. 3i Atlas, as many knows or many doesn't know it again yet. It's surprising, but many people didn't have a clue. Didn't see news past about it in the big media. They don't talk much about it sometimes to time, but it's rare. We have a close approach of 3i Atlas to Earth, but a relatively close approach. Uh, Close approach, nothing dangerous at all, but it was far away near the Mars orbit, in fact. But we have new pictures, and again, uh, it won't be it won't be based on NASA pictures. We're still waiting for them or not, maybe. But to talk about this, I will have the interview with Professor Avi Loeb again, professor of science at Harvard University, uh, doctor in physics, director of the Institute of Theory and Computation, and with the Harvard-Smithsonian Center. Voilà, for astrophysics. So thanks again, Professor Avi Loeb. Welcome.
Thanks for having me.
Yes, with pleasure. And again, we still have this kind of no show from the NASA and other organization officials one. Even I don't know if you heard that, but there was a question asked to Vladimir Putin about this, and he kind of laughed at it, but he has the same answers as NASA. That's kind of strange. Do you think so?
Well, first of all, it was interesting that he knew the numbers. He must have
Yeah.
discussed it with some scientists. My guess is the question was planted and approved in advance, and
Mhm.
he just, for some reason, I mean, I'm not sure exactly what the reason is. It has to do with public relations. He wanted to address this. But indeed, I mean, this is the narrative one gets, not necessarily just from NASA, but from the mainstream of the comet experts as well. Basically, from the beginning, when the object was just discovered, when we didn't have a lot of data, it was argued that it must be a comet. I should remind everyone that this was also true when Oumuamua was discovered, the first interstellar object, back in 2017. It was classified as a comet. And then we had very deep observations with the Spitzer Space Telescope back then, and no dust or carbon-based molecules were found around it. And so the limits were very tight on it being a comet. So then they changed the definition to an asteroid, meaning a bare rock without any ice on it that would sublimate as a result of the illumination by sunlight. But then after that, after it was classified as an asteroid, it exhibited non-gravitational acceleration,
Yeah.
which is a signature of comets that have the rocket effect on them. So
Yeah.
then the definition changed, and they said, well, maybe it's a dark comet where,
Mm.
it's a comet, but you can't see the signature of a comet. And so
Yeah.
the way that the mainstream comet experts respond to objects that they don't fully understand is always to classify them in terms of something they know. And
Mm.
that is understandable because that's the way AI systems operate. They base their answers on the training data set. And if the training
Wow.
data set of comet experts is just icy rocks in space, they would say anything that they see must be an icy rock. Now, we know that we launched the technological equipment to space, and in my view, we should expand the vocabulary of comet experts, because when objects arrive from outside the solar system, we don't know that they are icy rocks. They could also be technological objects. And because we put out such objects near Earth in addition to the rocks that are near Earth. So we know it's, there is a possibility that there was another civilization which is more accomplished than we are and managed to reach us. We should allow for that. And the only reason for us to consider that possibility is if there are anomalies, if things do not line up with what we expect. That was the case of Oumuamua. Things did not line up It was not a comet in the standard way, and it was not an asteroid in the standard way. So we should have allowed for a third possibility. And the comet expert did not want that. So they announced it as a dark comet just recently, about a year ago. And when we see the response to 3i Atlas, we should keep that in mind, because it means that when there are anomalies, these established experts would decline to explain the anomalies and claim that the object is well understood. And that's actually unprofessional, because if there is something that is not explained, it needs to be admitted. Okay.
Yep.
I didn't hear any discussion of the anomalies of 3i Atlas in the NASA press conference or
Nothing.
in
Nothing.
message. Basically, they say, comets are sometimes weird, and this one came from an unusual environment, not necessarily the same as the solar system. Therefore, we should allow it to do whatever it wants, but it is a comet. And I just don't accept that, because on January 2nd, this year, 2025, there was a near-Earth object. It was classified as an asteroid by the Minor Planet Center, which is the official organization. And then
was it the Borisov?
No. This was January 2nd this year, 2025.
Yeah.
Borisov was discovered in 2019.
Anyway,
so
another, it was then a third object, if we can say so.
No, I'm just talking about a completely different object that is bound to the solar system, not interstellar.
Okay, this one
and the Minor Planet Center classified it as an asteroid, until a day later they realized that it follows the trajectory of the Tesla Roadster car that was launched by SpaceX.
Oh, okay.
This is the real situation. So the only reason they called it a car and not a rock, an asteroid, is because they knew that SpaceX launched this object. But if someone else launches an object, they will always classify it as a rock or an icy rock. So the fundamental thing is that science, is not just making declarations. Science is trying to figure out things, to understand the nature of things. And if we see anomalies, we should attend to them. We should say, okay, well, we believe it's a comet, which is basically, I'm saying most likely it's a natural object, but we should admit that there are things we don't understand, and therefore we should take seriously alternative interpretations. Maybe it's not maybe it's like the Tesla Roadster car that was thought to be a rock and it's not. So in order to figure things out, we need to understand, for example, there is an anti-tail coming from this object towards the sun. And it was prominent from the beginning, from July. The Hubble Space Telescope took an image of the object on July 21st, and there was a glow extending towards the sun by a factor of 2. And that was a projection effect. If you correct for the projection, it's actually extending towards the sun by a factor of 10, meaning that it's a jet 10 times longer than it is wide. We see the same jet pointed at the sun. We can see it in the image that you are showing us.
Yeah,
it's basically the jet going to the lower left corner, which is the direction of the sun. I mean, we see a tail, but also this anti-tail. And
about this picture, again, for the people, now I will show some of the picture where they're called amateurs astronomer, but I disagree with this term. For me, it's now professional astronomers. And because, again, there's a no-show of our institutional things. I saw the picture that the probe, even the NASA probe, I think it was Juno, took. It was a lame. Again, there's another one.
No, it was not Juno. It was near the Mars Reconnaissance Orbiter, the high-rise image, and it was very poor resolution. Yeah, so the images that we see from people with equipment of just a few $1,000s actually inform us much more than the high-rise image.
And did you saw this one? This one is different from the others. We saw a more elongated thing. if we can say so. It's strange, but when you saw, because all these images were took for the people to understand when the comet was closest to the orbit of the Earth. Sorry, but closest mean near the Mars orbit. But when you saw these last images, what was your first reaction? Like, and this one again, it's fantastic.
Well, yeah, this one. Now, so there is this anti-tail, and it goes to a distance of about 1,000,000 kilometers. We've never seen such a jet pointed at the sun coming from a comet going to distance of 1,000,000 kilometers. And the question is, what is the physics behind it? Can you get a tightly collimated jet from the evaporation of a pocket of ice on the surface of a rock? I would argue you can't, because if you have just a pocket of ice on the surface and it gets illuminated by sunlight, it would basically, the gas would go in all directions and cover a full hemisphere, and then eventually get deflected by the solar wind and carried out in a tail. That's why we see a tail for comets. Instead, here we see a tightly collimated jet. How do you get collimation? The only thing I could think of is if you drill a hole on the surface of the object, but then the chance of sunlight getting through the hole to the bottom of the pit
No, no.
where there is ice is very small. You will get it only for a small fraction of the time. So it's not easy to collimate a jet. And before people say we understand the nature of this object, they should tell me, how do they produce a tightly collimated jet pointing at the sun, going out to a distance of 1,000,000 kilometers?
And for the people to understand that, what is 1,000,000 kilometer? What's the distance? I think.
Oh,
Can we say
that's about 2.5 times the distance to the moon. Okay,
that's
we're
huge?
talking. Yeah, it's a huge distance, and there needs to be an explanation for that. Another aspect is that there was a new paper a week ago that basically concluded that the rotation axis of the object was back in July and August was pointed towards the sun to within 8 degrees, and the jet, this anti-tail, was wobbling around it, and the anti-jet is also collimated to within 6 to 8 degrees. So the question is, how do you get this geometry set up as a random process? Why would the rotation axis of an object coming from a large distance, why would it be aligned with the direction to the sun? This is very unlikely. It's a 0.5% chance to happen at random, and also to have a pocket of ice just at the pole of the object, so that you will get the jet to be wobbling at a small angle in the same direction. And then when the object passed closest to the sun, suddenly, again, we see an anti-tail pointed at the sun. So that needs to come from the opposite pole.
So you were talking about the rotation axis, because for people to know,
Yes.
For me, and I saw again a picture of an professional astronomer. It was like a faster rotation, like Oumuamua, maybe like the kind of spin, but
Well,
more
no,
rapid a little bit. There's a
well,
wobbling.
Oumuamua was rotating every 8 hours.
8 hours,
This one is
yes.
every 16 hours. So it's about a factor of 2. Yes.
And this wobbling, your article about that 40th anomaly of 3 Atlas, alignment of its rotation axis with the sunward direction at large distances. We have new data, and what can you tell us about this anomaly?
Yeah, so this is a very unlikely geometry of having the rotation axis in the direction of the sun. That means the object has a permanent day side when it approaches the sun at large distances, and a permanent night side. The Earth is rotating roughly perpendicular to the direction to the sun. That's why along the equator, night changes to day, and then night again, and day and night. But if you imagine the Earth rotation axis being in the direction of the sun, then there would be a permanent day side and a permanent night side. And the question is, why did 3I Atlas arrive with this alignment? The chance of that is 0.5%. And then on top of that, there needs to be a base that is launching the anti-tail from near the pole, again with a chance of 0.5%, because it's within 8 degrees of the pole based on the wobbling.
It's mostly impossible for a natural object to do that. Can we agree with
Well,
that?
it just requires an explanation. So the point is, you can't say you understand the object without attending to the anomalies like this one, because science is, work in progress, and we need to explain things before we claim the victory that we know what the object is. The alternative is, of course, this antitail is produced by some technological thruster, and you may ask, what would be the purpose of that? Well, one possibility is if, for example, if a technological object wants to mitigate the solar wind, just to reduce any impact of energetic particles from the sun on the object, then obviously there will be some plume of gas or a jet that goes in the direction of the sun throughout the trajectory, just to block the solar wind.
Yeah, this is a thing that we could, again, we don't have the full details about it. And your article about like 3i Atlas in yours Earth, and we talked about it a little bit earlier, but I found it very interesting because, again, a blunt message in a bottle was delivered to Earthling on December 19, 2025. So you think, yes, we receive maybe an answer for what we send in space ourselves, by the way.
Right.
Some find this message insulting, but I like this article. I think you're right. And about the journey taken, so with the speed traveling to Milky Way disk of star must have taken billions of years, if so. But again, it could be earlier also. We don't know. We lack of data. But the interesting point: Jupiter is the center of attention because of its mass. Yes. So your hypothesis is that in your Earth it was late, but again, the orbital plan of this thing is nearly our own plan, and it passed to Mars. Have a good looking of Venus, see us, see the Earth the other way, pass to behind the sun, and see us again. Now we are on clear view sight, and is going on right now to Jupiter. And
Right.
at first we have the orbital plan to behind Jupiter, but now it's in front of Jupiter. Am I correct? Because maybe there was again another correction of trajectory or not?
Well, it will arrive to Jupiter at a distance of that is very close, 53.5 million kilometers, very close to the distance where Jupiter's gravity dominates over the tide from the sun. And it's an interesting coincidence again. But in terms of the Earth, it was passing closest to the sun at the maximum distance from Earth. It was on the opposite side of the Earth relative to the sun. So the sun was in the way for us to observe it. And it's clear to me that it was basically, irrespective of what the origin is, this trajectory was basically not paying too much attention to Earth. And so I got, for example, a question today whether this object was known to shed the cyanide and hydrogen cyanide, which this is a poisonous gas that was used that was used during the First World War as a chemical weapon. And so I was asked whether any of this material will reach the Earth. And turns out that at a distance that is only a few million kilometers from 3i Atlas, the gas gets so dilute that it will be swept up by the solar wind away from the Earth. So a distance of a few million kilometers is an order of magnitude less than the separation between 3i Atlas and the circle of the orbit of the Earth around the Sun, which is about 50 million kilometers. So there is no risk of the gas coming from it reaching the Earth. The same is true for dust particles that they may have been shed, because if they are of the size of a micron or less, they will be swept away by the solar radiation pressure. If they are bigger than that, let's say bigger than a millimeter, then they will not be affected. by the solar radiation or the solar wind. However, they will burn up in the Earth's atmosphere when they enter. And so then the only objects that could survive entry into the Earth's atmosphere need to be bigger than about half a meter. And that means the abundance of such objects, based on the mass loss rate of 3 Atlas, the abundance of them would be so small that the chance of them hitting the Earth is extremely small, unless, of course, we are dealing with a technological mini probe that can maneuver based on some propulsion system. But other than that, anything shed by 3 Atlas will probably never reach the Earth.
Okay, because the Earth will continue, of course, its course around the sun. But again, in the past, we saw some microparticles from other comets that we saw in the sky, like small meteors, but it was not. And there were long time ago histories of bad comets, like they were seeing green comets like that, and having maybe a cyanide effect on Earth with the gas.
Obviously, some asteroids and comets collide with Earth,
Yeah,
and they deliver whatever they have. They spread. Definitely, our environment affects the Earth, but the amount of mass associated with such impacts is really small, and we don't have to. I mean, events that affect life on Earth are extremely rare. So
we don't want this now.
Yeah, that's dealing with natural objects, of course. And if there is anything technological, we cannot really tell what the impact would be, because it depends on the intent of the technological object and the capability.
We don't have the data, of course, but the probabilities are special right now. And again, our Jupiter thing. Do you think it would be with this its current speed? Do you think it could use Jupiter to make a U-turn to see us again?
Oh, no.
No, that's impossible.
No, but it needs to come much closer. I mean, it could, in principle, it could make a U-turn, but for that, it needs to maneuver, significantly to come very close to Jupiter. I mean, if it were to come very close to Jupiter, it may actually get enough speed from the gravitational deflection by Jupiter to go towards Earth. But for that, it needs to maneuver a lot, because as of now, the trajectory passes within 53.5 million kilometers from Jupiter. That's too far for Jupiter's gravity to have any meaningful impact on the trajectory. By the way, the sun also didn't have much of an impact. It only deflected 3I Atlas by 16 degrees from the original path. So there was a slight deflection by the sun, but given the distance of 202 million kilometers, it wasn't, the sun's gravity was not strong enough to curve the trajectory by a lot. I mean, that was not true for Oumuamua, which was moving much slower than 3 Atlas, and therefore was affected much more by the sun's gravity.
Yeah, so you don't see now you have, for you, it's not the same kind of object like Oumuamua, or it's a totally different one. We can't.
Oh, very different. First, in terms of the size, at least an order of magnitude bigger, and also in terms of the anomalies. I mean, 3 Atlas does have a plume of gas around it and a jet coming from it. Oumuamua didn't show any such gas or dust around it, and it was showing non-gravitational acceleration nevertheless. Also, Oumuamua was most likely flat. It had an extreme geometry, because the amount of light reflected from it changed by a factor of 10 as it was tumbling every 8 hours, whereas 3 Atlas has very mild variation of its brightness, even though it rotates. But one has to remember, to keep in mind, that the variations in the amount of light that we see as the object rotates are probably a result of the jet coming from it, which scatters sunlight. And so it's not necessarily the shape of the object that dictates how much variation there is in sunlight. It's It's actually the rotation of the jet that modulates the brightness of the plume of gas around it.
And again, this object changed color also 3 times. We must remember that.
Yes. Yeah.
uh,
No, it's
I,
really strange. Yeah.
I have
By the way,
okay.
I should say you started the conversation by mentioning that NASA didn't release any exceptional data. I mean, there was the second image by the Hubble telescope that was about a week after the NASA press conference, and that, I mean, that was taken after the object passed closest to the sun, and about a month later, on November 30th. And
Yeah.
it does show.
This is, do you think, do you talk about this one? No, this
Yeah.
was, yeah. This
Is
was
this?
from
No,
released from
this is
NASA.
Mars. Sorry, this
No,
must
Mars. Okay.
be a different one.
No.
I'm talking about the Hubble image that was obtained at the end of November. So that was a very interesting, but the data has yet to be analyzed. It's not. They just showed us the raw image. I'm waiting mostly for the Webb telescope data that could give us the spectrum of the source, because I want to know the speed of the jet, and that you can infer by the spectral lines of atoms or molecules. And it would be very important to figure out the velocity, because just the sublimation of pockets of ice by sunlight would give us a speed of only a few hundred meters per second. But if the actual speed is bigger, then it may be a technological signature. What you are showing us is an image that was released from the Europa Clipper.
Yeah, exactly. Because I'm on the website even of the NASA, but they don't show much about what they, they discover so far. Eh, we have difficulties to find it. Maybe you talked about
Yeah,
this
this one.
picture,
This
this
one
one.
is
Yeah.
the second. Yeah. So it was taken on November 30th, and
Yes.
it's the second image, but now it's after perihelion, when the object came closest to the sun. And now we can, I mean, if there was an analysis of this that I mentioned in one of my reports by
Yes.
Tony Scarmato, that did the gradient filter on this, and you can see that there is a jet pointed at the sun. So that
Yeah.
is the antitail
Yeah.
in this image. I mean, it's difficult to see it from this image, but once you take the gradient of that, then you find.
Yeah, and again, we have to manipulate ourselves the pictures, but it should not be that way. Traditionally, we were used to have better pictures of Hubble or James Webb
Yeah.
Telescope on ESA, but again,
Well, but
it's
okay,
yeah.
so you have to keep in mind that the reason that we don't see the nucleus of 3A Atlas is because the scale of the nucleus is roughly the size of a city. It's kilometers. That's the order of magnitude.
It's smaller object than planets, of course, and other, yeah.
No, but if you just the issue is not how small it is. The issue is the angular size that it occupies at its distance. So if you take that scale of even 10 kilometers and divide by the distance from us, for example, it's 169 million kilometers, right? That is the distance at closest approach to the Earth. So if you take 10 kilometers and divide by 169 million kilometers, you get an angle that is much smaller than the resolution, the angular resolution of our telescopes, all of our telescopes. Even the Hubble Space Telescope, which gave us the best image, it can get at best about 50 kilometers per pixel at close. So it wasn't able to resolve the nucleus, and that's why we basically see a fuzz. We can't. The brightest pixel is much bigger than the actual object.
Yeah.
By the way, if we were on the other side of the sun in October, so in other words, if we were 6 months earlier at that location, we would have been able to map 3I Atlas by radar. We have existing radar systems, and at a distance of about 50 million kilometers, that would have been the distance of 3I Atlas if we were on the other side of the orbit of the Earth. At that distance, we could have used existing radar systems to image 3A Atlas as it rotates, just the nucleus. because the resolution of radar systems would have been good enough for us to actually measure the size and the shape as the object rotates if we were to take snapshots. So unfortunately, we were much farther away. We were at a distance that was instead of it's a distance that was about 7 times bigger. So we couldn't really resolve it. And radar, the amount of light reflected by radar systems it scales inversely with distance squared, and the flux that you receive goes inversely with distance to the 4th power. So changing the distance by a factor of 5 or 10, means that your flux, the flux that you receive at your radar back from the object, is down by
interesting. Sorry, but
5 up to 10 to the power 4. So it's a very negligible flux. But if we were to be closer to it, we could have imaged it with radar.
So radio telescope, we should have more data, more precise data.
Well, radio telescopes, we can see it emitting at millimeter wavelengths. We see molecules that emit at millimeter wavelengths, and there was data reported by ALMA, for example, that's in Chile. They observed, for example, methanol, which is 100 times more abundant in the gas around 3I Atlas than hydrogen cyanide, which in a way, it's good to have methanol rather than cyanide, because methanol is one of the building blocks for life as we know it. So we can see specific molecules in the millimeter wavelength, but that's not sufficient for us to resolve the object. We need to go to shorter wavelengths. There is no, basically, we don't have the resolution for any of the telescopes on Earth. Or in space, we don't have the resolution sufficient to observe the nucleus. One way to see the nucleus, of course, would have been to fly a spacecraft with a camera close to 3I Atlas. We could have done it, for example, the Juno spacecraft around the Jupiter. If it kept the original fuel that it started with, it could have intercepted 3I Atlas and given us a high-resolution image of the object. But unfortunately, they used more than 90% of the fuel already, so they can't do it.
The only probes we used, I think, were effectively Europa Clipper and JUICE.
Yeah, but they never came closer than 50 million kilometers, so it's still quite a large distance. That was also true of the orbiters around Mars, that they were at a distance of 30 million kilometers from
the one that broke down, or they lost contact with it.
Yeah, well, that's one of them, Maven, and NASA doesn't know what happened to it. It happened 2 months after it took data on 3I Atlas, and it used to be there for 11 years. And then there is the second one, the HiRISE camera on board the Mars Reconnaissance Orbiter, that gave us a very fuzzy image, not very impressive. That was the reason why I thought that having the press conference from NASA,
this one
was not very informative. They just didn't show us impressive images. They should have waited until the Hubble image at least is obtained.
Yeah. Okay. So thank you very much. And again, it was an interesting 2025 year about this. Many people discovered the world of so-called comet or 3I Atlas. Many people will be more informed now. They will more. They will watch the sky more, and even it's an interest for many people now. So even my family, someone will receive a telescope this year. He wanted to see himself with a good one.
Yeah.
So
you can see it with a telescope bigger than 20 centimeters, and it's a lot of fun. So if you can ask for a gift for the holidays, just ask for a telescope bigger than 20 centimeters so you can see it. I really hope that in the coming weeks, maybe within a month or so, we will start seeing data that was taken around this time, because it takes time for these research teams to put out the data and release it in the form of papers. It could take even a few months if they are reluctant to share the data before their paper gets refereed in a journal. But at any event, this additional data should give us many more clues about the nature of 3 Atlas. And only after we get this data, I will be happy to update the rank of this object on the Loeb scale, which is something I would very much want to do. Because 0 on that scale is a natural object, 10 is a alien technology of potential threat to humanity, and we should
So
see
for
what.
you now, does the number change, or is it
I
still?
haven't I haven't updated it because I'm waiting for the best. I mean, the best is yet to come in terms of data, and the best data was collected already this week or maybe in the coming weeks. But
Yeah.
it should give us so much more information that it would be foolish of me to give an update before I see that data.
I understand you because yeah, you're based on fact and science. I understand, but
Yes.
I remember Oumuamua. There was more of press release. People were more curious about that, but now it's a silence about authorities around the world. Yes,
Yeah, but
again,
they cannot silence the collection of data because there are so many, there are hundreds of telescopes around the world, and one way or another we will get the data irrespective of the official standpoint at this time.
thank you very much. That's the hope for 2026, having access to more data. And we encourage people to look at the sky, to take pictures, continue to take pictures another place. And we have even emitting signals. Did you? We talked about it the last time, but there could be a new 25 hertz, megahertz, I think, pushed on from the subject. It's like more artificial signals or not, we don't know, but it's strange again for a comet, for a rock and ice to emit radio signals. No.
Yeah, if it's, I haven't seen the data itself, but if there is a radio signal that is robust and definitely from the direction of the Atlas, that would be extremely interesting. So my advice is to stay curious, keep following updates, and we might learn many new things about. I'm definitely convinced that we are missing important information about 3 Atlas, and that is because of all the anomalies that it exhibits. So let's just see how we figure out what it is, the nature of the object. That's the way science is done. And there was a recent interview that I had just a couple of days ago, and on News Nation, where they asked me, what do you think the nature of the object is? And of course, as usual, I said, it's most likely natural, but nevertheless, it has these anomalies. So we should obviously study those anomalies before we claim that we understand this object.
Yeah.
And they thought that they argued that their digital team, when they put the video out, they suggested in the title that I changed my opinion, but I didn't change my opinion at all. I actually, and I wrote an essay about it yesterday. So you can find it, the latest essay.
The latest is not this one, because we're talking about 15 anomalies, but now we could have more. Maybe we don't know.
Yeah, no, it's the essay, 2 essays after that one. You can find it. It's the one from yesterday, and basically I pointed out that the way science is done is not through interviews on television. It's by looking at the data. So it's like the work of a detective. So let's stay curious and figure out what this object is.
Yeah, so you're talking about the classification of A3 Atlas yesterday, updating the Loeb. No, not this one.
Yeah, updating the Loeb. Yes, exactly, this one. Yeah.
And Jupiter is the next target. So we'll see if there's something else that will arrive, and it can prove this object can pass through near maybe satellites also of Jupiter, by the way, like Ganymedes or Callisto, whatever.
Well, let's see if anything unusual happens near Jupiter. That'd be really interesting. So thank you for having me. It was a pleasure speaking.
Yeah, and have a happy holidays. Thank you very much for your work. And we'll meet again in 2026 with new data. We hope better data, and maybe having some disclosure of something. So thank you very much.
Well, I'll be delighted to give you an update.
My pleasure. Thank you very much. Have a good day.
Bye-bye.
Bye. So it was Professor Avi Loeb again from Harvard University. Many questions. We still have many questions again. It's not all solved. We will have to wait again. Be patient. It's hard to be patient. We want answers. And again, yeah, um, he's carrying the informations uh, with care. So it's not just a show to say things, to say fluffy things or invent some things. It's important, but again, mm, we don't have all the information yet from the big medias and from the big institutions, but we'll have them sooner than later. So thank you very much, Biden. Share this video, please. And for the people speaking French, pour les gens qui parlent français, l'entrevue sur YouTube, subtitles in French, les sous-titres en français et les autres. Alors, merci beaucoup. Alors, have a good day. See you in the news later at 1 p.m. Bye.